acid. We have the balanced simple equation. Zinc plus 2 lots of hydrochloric acid forms zinc chloride and hydrogen. A. Explain, in terms of energy and bonds, why the reaction between zinc and hydrochloric acid is exothermic. So an exothermic reaction is one that overall gives out heat energy. Well, let's look at each stage. There will be bonds in both the reactants and in the products. When we break bonds, we have to put energy in. So energy is put in to break the old bonds in the reactants. As the reaction goes on, the products form, and there'll be bonds within those product substances. So energy is released when new bonds form. Now, the reaction overall is exothermic. It gives out heat energy. So that shows us that more energy is released when the new bonds formed than was taken in to break the old bonds. So more energy released than taken in. B. Write a half equation to show the oxidation of zinc in this reaction. So in the top equation, we can see that we start with zinc on the left-hand side. And on the right-hand side, we end up with zinc ions in the zinc chloride. Now, chloride would have a minus charge, and there's 2 of those. So the zinc is going to have a 2+ charge. In fact, zinc, although it's in the middle part of the periodic table, always has a 2+ charge. So it's balancing in terms of the zincs. We've got 1 on the left and 1 on the right-hand side of the equation. But unfortunately, at the moment, it's not balancing in terms of the charges. The left-hand side has no charge, it's neutral. But on the right-hand side, we've got a 2+ for the zinc and a 1- on the E- or electron. So on the right-hand side, we've got an overall charge of +1. Now, obviously, we must have the same charge on both sides. So we need to have an extra minus charge. So I'm going to put a balancing number of 2 in front of the electrons. So that now has on the left-hand side the zinc atom, which is neutral. And on the right-hand side, we've got zinc, which is 2+, and the 2 electrons that have a 1- charge each. So overall, that would also have a neutral or no charge, and our equation balances overall.